In this lesson, we will be subtracting polynomials. The most important thing to remember when subtracting polynomials is that subtraction is the same as adding the opposite. If you can keep that in your mind, then you will do well with these problems. You may have also heard keep, change, change. So subtraction is the same as adding the opposite. You'll keep, change, change. Let's talk about what that means. This was some basic subtraction that you should have done. 4 minus 7. So 4 minus 7, if we add the opposite and make it 4 plus, the opposite of 7 is negative 7. This is a way that we can change subtraction to addition in order to simplify this answer. As you become a more experienced math student, you no longer need to add the opposite and change it. You know that 4 minus 7 is the same as 4 plus a negative 7. Let's look at negative 3 minus 5. So adding the opposite, or you will keep the first number, change subtraction to addition, and then change 5 to a negative 5. So once again, negative 3 minus 5 is the same as negative 3 plus a negative 5. So let's see how that relates to our polynomials. Here we're going to have negative 3x squared plus 2x minus 7. We're going to subtract x squared plus 3x minus 5. So our steps to simplify these. Most important right now, the first thing is add the opposite. Or if you prefer to think about keep, change, change. Okay? So the first parentheses we're going to do nothing with. Keep that one just as it is. We're going to change subtraction to addition. So add. And then we'll do the opposite. But since there are 3 terms and this is a trinomial, we'll need to take the opposite of every term. So that means a positive will become a negative. A positive again will become a negative. And a negative will become a positive. Adding the opposite. That is the most important step. Once you do that, you combine like terms. So we have combined like terms before with adding polynomials. If you want to keep your work as this horizontal line, that is perfectly fine, but it also is helpful to line it up vertically. So that would be negative 3x squared plus 2x minus 7, just writing the first polynomial as it is, and then we'll add, lining up the like terms of the next polynomial. So negative x squared minus 3x plus 5. Being careful to line up those like terms. So negative 3 plus negative 1 gives us negative 4, leaving that as an x squared term, because when you combine like terms, your answer is that like term. 2x plus negative 3x gives us negative 1, which we don't have to write, but you could put there if you wanted negative 1x. And then finally, negative 7 plus 5 gives us negative 2. Let's take a look at example number 2. Here we have 2p. We're going to add 5q for that binomial. And we're subtracting negative 4p minus 2q plus 3. So that trinomial. So let's do our adding the opposite, or keep, change, change. And keep our first polynomial just as it is, rewriting it just as it was. Change the subtraction to addition, and then the opposite of every term. So make it a positive 4p, which actually in this case we wouldn't really need the plus sign. We know if it's not does not have a sign, it means it's positive. Positive 2q, and then the 3 becomes negative. So keep the first polynomial, change subtraction to addition, and change the signs to be opposite. Subtraction is the same as adding the opposite. So let's line up our like terms. We have 2p plus 5q. We'll line it up with our trinomial and add them together. Again, making sure, one, that you copy the problem correctly, but making sure that we line up our like terms. Let's combine them. We have 6p plus 7q, and we'll just bring down that minus 3 since we don't have anything to combine with. Let's look at now number 3. Here we have 3x squared plus 2x plus 4. We're going to subtract x squared plus x plus 2. Feel free to pause the video and try this one on your own. So we're going to keep the first polynomial, 3x squared plus 2x plus 4. And then we're going to add the opposite, being sure that we change all the signs. Adding the opposite to everything in that polynomial. We do want to combine our like terms, so lining them up, 3x squared plus 2x plus 4. We will add that with lining up our like terms from the next polynomial, negative x squared minus x minus 2. So 3x squared plus a negative, this is 1 if you need to write in that 1. So 3 plus negative 1 is 2, bringing down our x squared term. 2 plus, again, this is 1, so negative 1. That would give us plus 1x, which we don't really need the coefficient of 1, but you could show it. And 4 plus negative 2, so that's plus 2. Let's look at now example number 4. For this problem, we're actually going to start off a little bit different. Let's let a equal a polynomial 4x plus 1. B is going to equal negative 3x plus 7. And C equals 9x minus 2. So in order to work this problem, we're actually going to find what A minus B minus C equals. Well, we first have to start by substituting because we're given a value for A. Now, yes, it's this polynomial value, but that's still what it equals. We need to substitute in. So 4x minus 1, we substitute in for A, minus, notice we want to subtract B. Because B is represented by a binomial, 2 terms, we want to make sure we write parentheses so that we can subtract all of what B represents, the negative 3x plus 7. So use those parentheses so it doesn't look like you only want to subtract the first term. You're telling yourself you want to subtract all of what B is representing. And then do the same for subtracting parentheses. Plug in the value for C. Really, anytime you use substitution, I recommend parentheses. It just works better in math. Not only in this case, but in other cases we'll work through as well. So always substitute using those parentheses. So let's do what we've learned for subtraction. Keep, change, change. But notice we've got adding the opposite here for this subtraction, and we'll have to do adding the opposite here for this subtraction. but the first binomial doesn't change. 4x minus 1 will stay as 4x minus 1. We will add and then take the opposite of the term, so a positive 3x and a negative 7. But again here, we need to add and do the opposite. Negative 9x and a positive 2. Because there's been so many things going on with this problem, always take some time to stop and check over just simple things like your signs can make a big difference in your final answer. So we kept the first polynomial, added, and make sure you really took the opposite of each term. Something so simple as changing a sign will mess up the whole rest of the problem if you haven't done it correctly. Adding, and again, the opposite. So we feel good that we've done that correctly. We can now move on. Let's line up our like terms. So we have a 4x minus 1. We're going to add that with 3x minus 7 and add it with negative 9x plus 2. So I'm going to go ahead and just add them all as one problem together. If it would do you better to just add the binomial, the first two together, and then add the third one, do it whichever way works best for you. So we're going to take and of course add these values together. We have 4 plus 3 plus negative 9, or just minus 9. It's the same. So that gives us a negative 2. And of course it's a x term. And we have negative 1 minus 7 plus 2. So that gives us negative 6. So that is our answer in simplified form. Let's take a look now at example number 5. Here we are going to actually start with a rectangle. This rectangle is going to have an area that is equal to 10x to the third minus 5x squared minus 3. But inside of that rectangle, we'll have a smaller rectangle. And that smaller rectangle has an area that is negative 7x squared minus 8. So if I shaded the region of the larger rectangle but does not include the smaller rectangle, we could find the area of the shaded region. So let's do that. Find area of shaded region. So let's think about how we could do that mathematically. If I know the area of this larger rectangle that is given to me, and I have also the area of the smaller region, if I subtract the smaller area from the larger area, I'm left over with the shaded region. So that's how we can set up our problem. We have the area of our larger rectangle. We're going to subtract the area of the smaller rectangle. And when we do that, it will give us the area of that shaded region. Because if I know the area of the entire rectangle and I take away this piece that's not shaded, subtract that out, that leaves me left with the shaded region. So let's do our adding the opposite. 10x to the third minus 5x squared minus 3. We will keep that as it is. Change the subtraction to addition, and then the opposite of each term. So we have a positive 7x squared and a positive 8. Let's combine our like terms to simplify. Lining up our x squared terms. Be careful. I almost wrote that x squared term under the first term. That's an x cubed term. So actually the positive 7x squared will go here under the x squared term. And then the plus 8 under our constant that does not have a variable. We are now adding those together. We have 10x to the third since it had nothing else to combine with. Negative 5 plus 7 gives us 2. Of course, bringing down our x squared. And then negative 3 plus 8 gives us 5.